This video is a quick review of function notation. Recall that a function is a rule that assigns one output for each input. Here's an example of a function. This gives us a formula that tells us for each value of x we input, what the corresponding output would be for y. For example, if we plug in a 0, this formula tells us that the output is 1. If we plug in 2.5, this formula tells us that the output will be 13.5. But functions written in this way can be somewhat cumbersome, so we use function notation to help us. And the idea is to represent the rule with a shorthand. In this case, the f of x is our shorthand that represents the rule itself. Here's an example. Suppose we have a rule defined by the formula f of x equals x squared minus 2. We could use this rule to evaluate the output for certain inputs. For example, if I want to know what I will get out should I input the number 4, this rule tells me how to compute that output. Everywhere I see an x, I replace it with the number 4 because x represents the input and I'm inputting 4. Then we can simplify this expression. 4 squared is 16, and 16 minus 2 is 14. So if I plug a 4 into this function, I will get out 14. Similarly, if I plug a 1 into this function, everywhere I see an x, replace it with a 1, and then simplify, I'm going to see that the output, when I plug in a 1, is negative 1. The variable that represents our input does not have to be an x, and the symbol that represents our function does not have to be an f. For example, here we're going to use the function g of t, given by the formula t plus 3 divided by t minus 1. Let's see what happens if we plug a 6 into this function. So wherever I see a t, I'm going to replace it with the number 6. And then simplify. 6 plus 3 is 9. 6 minus 1 is 5. So if I input a 6, the output is 9/5, which you could also write as 1.8. Function notation can be really useful if we have lots of different formulas in our problem and we want to be specific about which one we're using. So here's a business example. Imagine that you are running a company that manufactures gizmos. You could use one function to represent the cost of manufacturing gizmos. In this case, if you plug in an x value that represents the number of gizmos you're going to manufacture, the output from this function, c of x, could tell you the cost for producing that many gizmos. You could also imagine another function, r of x, that would represent the revenue from selling a number of gizmos. Or another function that represents the profit from selling gizmos. And it turns out these quantities are related. You can obtain the profit by figuring out the revenue and subtracting the cost of production. We're able to express the relationship between these different quantities because we have a different symbol for each of them. P of x represents the profit, R of x represents the revenue, C of x represents the cost of production. If we didn't have function notation, it would be harder to represent this relationship.